Okay, today we will discuss about how to find solve the economic dispatch that presents of losses. Dia keluar tak keluar ni? Sekejap ah. Okay. So basically, in real world or real practical problem, when we deal with the economic dispatch, so basically we will include the transmission losses. Okay, in power system, so it cannot be avoided since when we we talk about the economic dispatch that related to the equality constraints. Normally, our equality constraints is equals summation of all the generation. Sorry, my pen must be equal to the P demand plus P loss. So if you remember, yesterday we talked about the equality constraints that just only consists of PD, right? So we ignore the losses. But today we will look at how we want to calculate the economic dispatch, or how we want to derive to solve the ED by including the transmission losses. Okay. So if you remember that our equality constraint yesterday, that we our pi is equals to 0 equals to P load minus the summation of the generators, right? So today we will include the losses. So this is the real equality constraints that we consider in our solution. Okay. So from here, when we do again, we can apply our Lagrange function. So we applied our Lagrange function into the cost function and the equality constraints. So we can see here that ft plus lambda pi, right? Okay, so and remember that our pi now is 0 equals to P load plus P loss minus summation of Pi. Okay, and then when we do the partial derivation, okay, do Lagrange function do with respect to the Pi. So we just do the partial derivation of cost function, each individual cost function with respect to the Pi. And then how can we obtain these things? So you do the partial derivation of the this expression with respect to the Pi, right? And we remember that we times lambda here. So lambda, when you do the expansion, you can get lambda P load, okay, and then plus lambda P loss, and then minus lambda P summation of the Pi, right? So when you do the partial derivation, so you can, because lambda is have in terms of Pi, and then when you do the partial derivation, you can get Pi is come out the lambda, right? But and then our load, our loss, P loss is consist in the equation. That's why you cannot you can avoid it. So you can get at the end of the day, when you do the rearrangement, you get this equation. Okay, and then you just make a simple arrangement, get the lambda as a title, get dFi over dPi plus lambda dP loss over dPi. Okay, and we know that this one is our equality constraint. So, but as you can see here, this is quite troublesome to solve because it's quite a non-linear and non-convex. So how we can solve using two approach. Okay, the first one, we develop a mathematical expression. So this one, when we have a larger system, let's say we have 40 generators. So normally we use B loss coefficient. The name is B loss coefficient. This result is not accurate, but it can be accepted. But if you want to get the accurate results, we can use load flow. Okay, meaning that you find the value of P, right? Using any techniques, and then you put all the P into the load flow system, and then you run the load flow, as you learn in power system analysis. Okay, and then you can get your loss. But not only loss, you can get many information like voltage, angle, as well as P and Q in the system. So this is very accurate results, but the problem is we may have known the generators coefficient or characteristics, but we don't know the transmission line punya characteristics, nilai R, X tu kita tak tahu. So itu jadi masalah lah. Okay, that's why normally we know the generator characteristic, but we don't know the transmission line characteristic. That's why when you load flow ni agak susah untuk guna. That's why normally, even though in the paper published in many journals, they use B loss coefficient. Okay. Okay, for this one, but in your class, I think should be simple lah. That is the equation is quite simple. But never mind, we try to look at this example. Okay, let's say I think a similar example with yesterday. So we have 3 generators which have coal-fired. Okay, coal-fired for unit 2. This one is our P1 must be operated between 150 to 600 megawatts. Okay, and then our P2 also must be operated between 100 and 400 megawatts. Okay, and it's given the heat rate curve equations, so you need to times with the unit price to get the cost function. Okay, similar we have with the P3 is between 50 and 200 megawatts. This one is quite simple, but basically later we will look at how we can derive the B loss coefficient using later we will take a look at the Hadis-Sadat new technique. This one normally just simplified where your loss is given. This one is coefficient, loss coefficient 0.00003 P1 square, 0.00009 P2 square plus 0.00012 P3 square. Okay, the question is similar with the previous, but now we consider the loss. So when we have the load is 850, this one is our demand, 850 megawatts. Now our price of coal is 1.1 ringgit, and our price for oil is 1 ringgit per MBTU. So how to do it? So similar with the previous example, we need to find the cost function for the unit number 1. You need to times with the oil price, the unit price. This one unit price for coal, this one unit price for oil, this one is for coal. Okay, this one is using oil. So when you do the calculation, you can get 561.7192 P1 plus 0.001562 P1 squared. So here you can say this is alpha 1, this one is beta 1, this one is gamma 1. This one is ringgit lah senang, ringgit per hour. Okay. This one is alpha 2, this one is beta 2, this one is gamma 2, this one is alpha 3, this one is beta 3, this one is gamma 3. Okay. Next you need to do the partial derivation. Okay. Do the partial derivation for this one. So df over dp with respect to p1. So this one is cancelled. This one p1 is cancelled. This one p1 maintained, but you need to times with 2, right? So that's why you get this value. 7.92 plus 0.003124 p1 equals to lambda. This one is with respect to the loss equation, right? This one. So you need to bring this to here, right? df1 over dp1 equals to lambda minus lambda delta p loss minus delta pi. So that's why you get here lambda, then 1 minus 2. This one is what? This one is 2 dp loss, right? With respect to p1. Okay, this one. So this one you have your loss equation here. So when you have dp loss over dp1, so with respect to p1 only, the rest is no need to be considered. So you get 2 times 0.00001234 p1. Okay, so this is the partial derivation. So that's why you get this equation. Similar with the equation number 2, unit number 2, you have 7.85 plus 0.00388 P2. This one is beta 2. This one is 2. Sorry. 2 gamma 2. This one. Okay, this one is beta 1 plus this one is 2 gamma 1. This one is beta 3, 2 gamma 3, P3. Similar, this one is 1 minus 2 because we have P2 square. So 2, this one is dp loss over dp2. This one dp loss over dp3. And then we have our constraints, equality constraints, and the equations. P1 plus P2 plus P3. Our demand is 850, and then we minus P loss equals to 0. Okay, so next. Normally the starting value is given in exam. So you just use the initial value that given by the question. So let's say we have P1 is 400, P2 is 300, P3 is 150. So you sum these things, this power generation, you can get 850 megawatts. Okay, so we pick this value for the starting value, and then you need to calculate your P loss. Since we know the incremental P loss, dP loss over dPi. So since we know already our P1, P2, P3, this one our P1, P2, P3. From here we know already that our dP loss over dP with respect to the power, and we also know the initial value P1, P2, P3. So you just put all the equation into this expression. So you can get your loss is equals to 15.6 megawatts. Next, we just put into the equation just now. This one unit number 1, this one unit number 2, unit number 3. We know already that this one is our equation is 0.024. You just put here. Okay. Okay. Solve this thing, right? So you put that there, and then the variables now left is your lambda. From this equation also, we just use yesterday's punya example. You can use matrix. Okay. You can get your lambda. So how you get your lambda? Boleh kira? Buat macam semalam. Okay, you have the P1, P2, P3, and then your lambda. Dia dapat ni. So you can rearrange using equation semalam lah. Atau you boleh pakai coordination equation where your lambda equals to your demand plus summation of beta over 2 gamma I kan, bagi 1 over 2 gamma I. Boleh pakai yang ni atau you boleh pakai matrix yang semalam tu lah. So at the end of the day you can get your lambda 9.5252. So you can get your value of P1, P2 and P3. You sum, you're supposed to get 800 megawatts. No, not 100 megawatts. You get 800 megawatts plus losses. Loss berapa? Loss 15.6. Cuba kira. Tambah 15.6, you akan dapat 865.6 kan? Itu 67. Cuba tambah semua, berapa dapat? Boleh cuba kelas? Kelas boleh cuba tak?
Yes, sir. Yes, sir.
Cuba kira, berapa dapat?
Dapat, sir.
Dapat berapa?
865.57.
Okay. Kurang lah. So ni cara, this is how we calculate, but normally for your information tak masuk exam lah. Simple. Yeah. Okay, so this is an example how we, but it's not as easy, simple or like this lah, because of what? Because of this, we can say that this value obtained is not optimal, not so optimal, because the power system is very complicated. You can get optimal results from this one. Is one of the techniques to get the. So lepas tu apa yang boleh buat ialah you put all this value into the cost equation, cost function, then you calculate the cost summation of this F. Okay, so you can get the value apa. So that is how we get the cost of generations, atau kita panggil the cost of economic dispatch. Okay. Okay, ni ada problem kan? Problem dia. Yang ni tak berapa ni lah saya. Okay, tak apalah, tengok kita just tengok je contoh ni. Compare P1, P2, P3 from the step 5. Step 5 is we calculate the value of lambda. We dapat P1, P2, P3. We compare your results compared to step 3. Ni, we compare dengan initial results. If there is no significant change or any one of the value, go to step 7 or down. Otherwise, you go back to the step 4. So sekarang ni you kena compare P1, P2, P3 dengan you punya initial value. Kalau tidak ada significant change, you stop lah. Ataupun kalau tak, you kena, ni kan significant change kan. Significant change maknanya you start dengan 400, 300, 150. Sekarang ni 440, 299, 125. So ada quite significant change. So apa yang perlu you buat ialah, since the values of P1, P2, P3 are quite different from the starting value, so return to step 4. You go for this value. You masuk balik your P1, P2, P3 yang you dapat. Okay, you put all the values that you have obtained in step number 5. Masuk this one, P1, ni P2, ni P3. Okay, so you dapat ni, yang ni, yang ni. Daripada sini you kira balik you punya loss. Kan, you masuk loss, you dapat 15.78. Next, you kira balik, cari lambda baru, you masukkan dalam equation, and then you repeat sampai tidak ada perubahan lah. So that's why you buat ni guna iteratively. So ni solution dalam bentuk table lah. So we start with the value here, 400, 300, 150, then you calculate your lambda, your loss, you get 16. Then you can get your lambda here. Then for the first iteration, you dapat value yang ni. And then for the next iteration, you dapat value yang ni. And then you buat sampai perubahan tu tak banyak. Okay, yang ni tak banyak. So kalau you run lagi sekali pun dia akan tak banyak beza. So you can stop. Sama juga yang lambda ni. Bila stop kat sini, kita boleh tengok sampai 4 iteration saja. Okay. Ni kita tengok nanti. Soalan? Kelas? Soalan tak? Tak ada soalan? Kalau tak ada soalan, kita stop kat sini. So, saya akan bagi you assignment. Okay, tak ada soalan Sebab saya rasa semalam saya buat kelas lebih sejam, video lambat sangat nak buat. Dan sebenarnya tak efektif. Suppose when we have a synchronous class, maksimum sejam je sepatutnya. Sebab unit credit hour is 2 jam. 2 jam. Kalau face to face 2 jam memang quick, okay lah. Sebab kalau saya buat video, asynchronous system ataupun cara tak synchronous, tak segerak, mana you tengok video tu saja, 10 minit is equal to 1 hour. Okay, 10 minit ataupun 15 minit tu lebih kurang dalam untuk per kelas lah, tapi you boleh refer video-video saya yang sebelum ni lah. Okay, so kalau tak ada, kita stop kat sini. Kita cuba saya bagi you assignment lah. Assignment tak lama. Okay, ni assignment 5%. You need to write the article. Boleh nampak kelas?
Nampak, sir.
Okay, so read the article. You find the article ataupun you find any relevant articles and then you need to write by yourself. Tak perlu banyak sangat. Okay, maximum 4 pages double column. Maximum. So minimum minimum tak ada lah. Kalau minimum sikit sangat pun tak boleh juga. So try to make 4 to 5 pages double column and submit to turn it in dan juga kalam. Okay, so article about effect of COVID-19 to power system industries, so you can include, you baca artikel dan you put synthesize ataupun you kena discuss lah. Okay, menulis sebab you kena menulis kan cara tulis report, bukan copy paste lah. Copy paste memang kalau turn it in boleh detect, dan bukan you copy paste gambar lah. Topik sini saya slow lah. Okay, assignment. Saya bagi masa berapa lama itu? Sampai hujung bulan lah. 31 bulan. Okay. Number 1, 5%. Banyak isu sekarang pasal COVID, so you boleh tengok lah. Itu ke? Itu. Oh, sekejap. Saya kena tukar. Due date 31st March. Day 21 before 5 p.m. Okay, assignment 1.
Group ke sir?
Individu.
Okay.
Okay, due date 31st March 5 p.m. You boleh submit banyak kali ya. Submit dekat turn it in boleh banyak kali. Kalau you punya similarity tu tinggi. Saya tunjuk sekali lagi dia punya rubric. Kalau hantar lagi macam mana rubric lah. So the assignment. Rubric, launch rubric. So ni rubric saya. Okay, ni bukan ni orang punya. Saya punya mana? Rubric scoring. Ada banyak rubrik boleh follow, tapi saya pakai rubrik saya lah, senang. People saja. So introduction 20%, criterion 2 is the content, your main content. And then your example 5%, conclusion 5%. Okay. And then yang antara yang terbanyak ialah similarity report lah. Kalau merah kosong lah. Kalau kuning separuh, kalau hijau full marks. Faham tak? Maknanya kalau you buat, walaupun you buat good articles but your similarity index is quite high, so you dapat rendah lah. Sama juga kalau you dapat hijau tapi saya detect you tipu. Saya sekarang ni kadang-kadang student dia menipu. So bila tipu kita, macam mana saya nak detect dia tipu? Content tu nampak okey tapi similarity index kosong. Tak betul lah. Dan dia punya type apa ni, dia upload gambar je. Dia print screen, dia letak balik dalam Word, lepas tu dia letak balik dalam PDF, submit. So yang tu tak betul lah. So jangan buat. Saya sekarang ni bersangka baik pada semua orang. Please, ni pun ada satu orang ni yang baru masuk dan dah masuk. Betul kan nama awak semua kan? Sila guna nama betul lah, jangan guna nama pelik-pelik. Kalau boleh letak nombor ID lah depan. Senang saya nak sorting. Kalau tak boleh, nama betul. Jangan nama Spiderman lah, apalah, susah saya nak sorting. Okay? Maka akan keluar kat sini lah. Saya akan marking guna turn in. Much better compare to saya marking kat kalam. Kalam ni just for your you submit. Tengoklah macam ni, kadang saya marking kat kalam, kadang kalam problem saya marking kat turn in. Okay? Okay, any question? Kelas, tak ada kelas, ada soalan?
Tak ada, sir.
Tak ada, sir.
Okay, kalau tak ada, so next week kita tengok benda. Next week kita akan masuk hadis hadap punya teknik. Tengok sikit-sikit dulu awak. Sikit dulu. Okay, so next week ada quiz lah. Okay, next week ada quiz. Tak ada apa-apa, tak ada cuti. Minggu depan dah Syakban dah kan? Sekejap je. Okay, kalau tak ada soalan kita stop kat sini. So see you next week. Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Thank you very much.
Thank you, Zam.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.